Hello everybody, welcome into another lesson. So today we are going to talk about solving quadratic equations using the quadratic formula. And admittedly, this is probably the last resort that you want to use. That would be if you couldn't factor the equation, or if you go to complete the square and you're going to have a bunch of fractions, then you probably want to use the quadratic formula. Now you can use the quadratic formula for any quadratic equation, but there might be times you're doing more work than you need to. But here, of course, you have the standard form of a quadratic equation, ax squared plus bx plus c. Now, the quadratic formula enables you to solve for x by taking the negative of your b coefficient plus and minus the square root of b squared minus 4ac all over 2a. So that is where it doesn't matter what your coefficient on x squared is, unlike when we completed the square. You could have any coefficient and constant. Now I'm going to leave the quadratic formula up here because it's a bit of a doozy to remember if you don't remember it. I only remember it because I've been doing it for so many years, but that's a hard one to remember. But let's say we have something like x squared minus 5x minus 14 equal to 0. So x squared minus 5x minus 14 equals 0. Well, definitely not going to factor. You could use completing the square, but this lesson's all about using the quadratic formula. So we'll take x, set that equal to the negative of b would be negative 5, so that'd be positive 5 plus and minus the square root of your b squared, so that's negative 5 squared minus 4 times your a, which is 1, times your c, which is negative 14, all over 2 times your a. 2 times 1 is just 2. So that's going to equal 5 plus and minus the square root of 25 plus 56 all over 2, which would equal 5 plus and minus the square root of 81 all over 2, which would equal 5 plus and minus 9 all over 2. So now you have two solutions. You'll have x would equal 5 minus 9 over 2, and then x would also equal 5 plus 9 all over 2. Alright, so what is 5 minus 9? That's negative 4 divided by 2 is negative 2. So x would equal negative 2. Now, we actually could have factored this. It's just they want us to use the quadratic formula. Then what is x equals 5? So 5 plus 9 is 14 divided by 2 is 7. So the two solutions are x equals negative 2 and 7. So even if you can factor, you can use the quadratic formula. It's just a bit more work than you need to. And I got more examples here. What if we had x squared plus 3x minus 2? Now this one you definitely can't factor. So x squared plus 3x minus 2. Well, set up your x. That's going to equal the negative of b, so that'd be negative 3 plus and minus the square root of your b squared, which would be 3 squared, minus 4 times your a of 1 times your c of negative 2. This will be all over your 2 times a. 2 times 1 is 2. So that would equal negative 3 plus and minus the square root of 9 plus 8 all over 2. And the best you can do in this case is negative 3 plus and minus the square root of 17 all over 2. there's no other way to break down the square root of 17, so x equals both negative 3 plus and minus the square root of 17 over 2. So if you can break it down, by all means do so, but the square root of 17 doesn't reduce any further. So that one you just leave as is. All right. We have 5x squared plus 3x minus 1 equals 0. Definitely not factorable. 5x squared plus 3x minus 1 equals 0. So let's find the quadratic formula. X would equal the negative of b. Well, that'd be negative 3 plus and minus the square root of your b squared, which would again be 3 squared, minus 4 times your a, which is 5, times your c, which is negative 1, all over 2 times your a of 5, so that'd be 10, which would equal negative 3 plus and minus the square root of 9 plus 20 all over 10, which the best we can do is negative 3 plus and minus the square root of 29 over 10. Because 29 doesn't reduce any further, so you get negative 3 plus and minus the square root of 29 over 10 for your solutions. Six p squared minus 8p plus 3 equals 0. So we have 6p squared minus 8p plus 3 equals 0. Well, let's do the quadratic formula. Your p is going to equal the negative of your b, so negative 8 is positive 8, plus and minus the square root of your b squared, which would be that negative 8 raised to the second power, minus 4 times your a of 6 times your c of 3 all over your 2 times your a of 6, which would be 12. So that would equal 8 plus and minus the square root of, which would be 64 minus 72 all over 12, which would give you 8 plus and minus the square root of negative 8 all over 12, which would give you 8 plus and minus. Now, what is the square root of negative 8? You have the I component, then you have 4 times 2, so that'd be plus and minus 2i times the square root of 2 all over 12. Well, notice here now, you're going to have, if you separate the two terms, 8 and 12 both divide evenly by 4, so you'd end up having 2/3 plus and minus, then you have 2i times the square root of 2 over 12, those both divide by 2, you'd have plus and minus the square root of 2 over 6 times I. So those are your two solutions. You have two imaginary solutions. You have 2/3 plus and minus the square root of 2 over 6 times I for your solutions to this. All right. X squared plus 4x equals negative 20. So we have x squared plus 4x equals negative 20. Well, in this case, since we're using quadratic formula, you want the right-hand side to equal 0. So add 20 to both sides. you would get x squared plus 4x plus 20 is equal to 0. Now that's better. Now we can use the quadratic formula. X would equal the negative of b, which would be negative 4, plus and minus the square root of your b squared, so that'd be 4 squared, minus 4 times your a of 1 times your c of 20, all over 2 times your a of 1, which would just give you 2. So that's going to equal negative 4 plus and minus the square root of 16 minus 80, all over 2, which would equal negative 4 plus and minus the square root of negative 64, all over 2, which would equal negative 4 plus and minus 8i over 2, which can reduce down into negative 2 plus and minus 4i. Those would be your two solutions. Negative 2 both plus and minus 4i is what you would end up getting. All right. So we have negative x squared equals 16x plus 46. So we have negative x squared equals 16x plus 46. Well, we definitely want the right-hand side to equal 0. So let's subtract both those terms from both sides. You would end up getting negative x squared minus 16x minus 46 is equal to 0. Now we can do the quadratic formula. X would equal the negative of b, well negative 16 is positive 16, plus and minus the square root of that b squared, which would be negative 16 to the second power, minus 4 times your a of negative 1 times your c of negative 46, all over 2 times your a of 1, so that'd be negative 2, is going to end up equaling 16 plus and minus the square root of 256. So that'd be positive 4 times negative 46. That'd be minus 184 all over negative 2. So that's going to equal 16 plus and minus the square root of, that would just be 72 all over negative 2. Well, 72 breaks down into 36 and 2, so this would turn into 16 plus and minus the square root of 36 times the square root of 2, so 6 times the square root of 2 all over negative 2, which will reduce into negative 8 minus 3 plus negative 8 plus and minus 3 times the square root of 2. So you end up with solutions of negative 8 plus and minus 3 times the square root of 2. Alright, let's see. 3x squared plus 6x equals negative 2. So we have 3x squared plus 6x equals negative 2. Well, for starters, we need the right-hand side to equal 0. So add 2 to both sides. You'll end up with 3x squared plus 6x plus 2 is equal to 0. Now we can apply the quadratic formula. X would equal the negative of b, so that'd be negative 6, plus and minus the square root of your b squared, so that'd be 6 squared, minus 4 times your a of 3 times your c of 2 all over 2 times your a of 3, which would give you 6. So that'd be negative 6 plus and minus the square root of 36 minus 24 all over 6. So this will turn into negative 36 plus and minus the square root of 12 over 6. Well, square root of 12 breaks down into the square root of 4 times the square root of 3, so that would become negative 6 plus and minus 2 times the square root of 3 all over 6, which would reduce into negative 1 plus and minus the square root of 3 over 3. So you get two solutions there. You'll have negative 1 plus and minus the square root of 3 over 3. Let's do a few more here. Do 2 to 3 more of them, then we'll be done with this lesson. We have 8x squared minus 8x is equal to 1. So 8x squared minus 8x equals 1. Well, you definitely want the right side to equal 0, so subtract 1 from both sides. You would end up with 8x squared minus 8x minus 1 is equal to 0. Now apply the quadratic formula. X will equal the negative of b, so negative negative 8 would be positive 8, plus and minus the square root of your b squared, that'd be negative 8 to the second power, minus 4 times your a of 8 times your c of negative 1, all over 2 times your a of 8, which would be 16. So that's going to equal 8 plus and minus the square root of, let's see, 64 plus 32 all over 16, which would equal 8 plus and minus the square root of 96 all over 16. Well, 96 breaks down into factors of 16 and 6. So you'll end up having 8 plus and minus 4 times the square root of 6 all over 16, which this would simplify into 1/2 plus and minus the square root of 6 all over 4. So you end up with 1/2 plus and minus the square root of 6 all over 4 for your two solutions. Let's do 2 more. All right, so 5x squared plus 9x is going to be equal to negative x squared plus 5x plus 1. So 5x squared plus 9x equals negative x squared plus 5x plus 1. Well, we definitely need to make the right-hand side equal to 0. So let's see, if you add x squared to both sides, you'll end up getting 6x squared. And then if you subtract 5x from both sides, you'll end up having 6x squared plus 4x. Then subtract 1 from both sides, minus 1, that would all equal 0. So you get 6x squared plus 4x minus 1 equals 0. Now let's apply the quadratic formula. X would equal the negative of your b, so that'd be negative 4, plus and minus the square root of your b squared, so that'd be your 4 squared, minus 4 times your a of 6 times your c of negative 1 all over 2 times your a of 6 would be 12. So that's going to be negative 4 plus and minus the square root of 16 plus 24 all over 12. So that's going to equal negative 4 plus and minus the square root of 40 all over 12. Alright, so what does the square root of 40 break down into? It breaks down into the square root of 4 times the square root of 10. So you would get negative 4 plus and minus 2 times the square root of 10 all over 12, which would become negative 1/3 plus and minus the square root of 10 over 6. So your two solutions are negative 1/3 plus and minus the square root of 10 over 6. Let's do one more. So we have 40x minus 7x squared would end up equaling 101 minus 3x squared. So we have things out of order here, but let's make the right-hand side equal to 0 first. So if we do that, we'll end up here with 40x minus 4x squared minus 101 is equal to 0. So let's put this now in descending order, the proper order for standard form. That'd be negative 4x squared plus 40x minus 101 would all equal 0. Okay, so now let's apply the quadratic formula. X equals the negative of b, that'd be negative 40 plus or minus the square root of your b squared, so that'd be 40 squared, minus 4 times your a of negative 4 times your c of negative 101 all over 2 times your a of negative 4, that'd be negative 8, which would equal negative 40 plus and minus the square root. All right, 40 squared is 1600. All right, so now let's take this whole mess. That'd be positive 16 times negative 101. That'd be minus 1616 all over negative 8, which would turn into negative 40 plus and minus the square root of negative 16 all over negative 8, which would turn into negative 40 plus and minus 4i all over negative 8, which reduces into 5 plus and minus 1/2 I. So your two solutions are 5 plus and minus 1/2 I. So that's it for using the quadratic formula to solve quadratic equations. The next lesson, we are going to be in the quadratic formula, but we're not going to use it to solve equations. We're going to talk about what's called the discriminant. And that'll tell you what the nature of your solutions are. So I hope everyone has a great day. Take care.